Hi everyone, in this video I'm going to explain Boxplot and how we can draw a boxplot in Microsoft Excel. Let's dive into the video to see how we can draw a boxplot. Right over here you can see we have some data about the teaching experience of some teachers of some XY educational institutions. Let me show you how we can actually draw this particular data in the form of a boxplot. So simply select the data like this and now go to Insert tab. In the chart groups, click on this particular option and there you can see box and whisker plot. Simply click over it and there you can see our box and whisker plot ready. First, let me explain what does this box and whisker plot actually shows. Actually, there are 5 key points in box and whisker plot. The first one is the minimum value. You can look at our graph and you can see the minimum value in our data is simply 5. And you can also use min function in Microsoft Excel to find it. Let me show you. You can simply write is equal and then use min function. Min, press tab, select the data like this and press enter. And there you can see the minimum value is 5. And this minimum value is represented by this particular bar at the end of the box plot. Similarly, we can also calculate the maximum value using max function. We can simply write is equal max, tab, select the data and press enter, and there you can see this is going to be the maximum value, which is 19 in our case. Within the box you can see we have this line. This is actually the median, which actually divides the data into 2 equal halves. And you can also calculate it using the median function in Microsoft Excel. So we can actually do it pretty easily. We can write is equal median, tab, and again select the data like this, press enter, and there you can see the median in our data is 13. And if you look closely, you can see this median line is right in the middle of 12 and 14. Now, the other two very important features in Boxplot are the first quartile and the third quartile. This bottom part of the plot shows the first quartile and the top of the plot actually shows the third quartile. And we can easily calculate them as well. Let me show you. The first quartile is Q1 and it can be easily calculated using the quartile function. So simply write is equal quartile. For most purposes, quartile.exe, that is quartile exclusive, is used. However, in some cases we can also use quartile inclusive. In exclusive, the median is not counted, while in inclusive, the median is also included in the quartile. Simply press tab and let me select the data, comma, and now since we are calculating the first quartile, so I'll choose 1. Now close the bracket and press enter, and there you can see our first quartile is 7.5. And similarly, we can also calculate the third quartile as well. So I would write again is equal quartile, again select the data, comma, and this time since we are going to calculate the third quartile or 75th percentile, so I would choose 3, again close the bracket and press enter, and there you can see this is 16.5 is our third quartile. Now the data between the bottom and the top of this box is called interquartile range. Or in other words, we can also say that the data between Q3 and Q1 is interquartile range, and we can calculate it pretty easily. Let me show you. So I would write is equal. Now simply select Q3 minus Q1 and press enter, and there you can see the interquartile range in our case is 9. Anything that is beyond the maximum and minimum value is called outliers. An outlier that goes beyond the maximum value is called a high outlier, and the one that goes below the minimum value is called minimum outlier, and we can easily calculate them as well. Let me show you how to calculate the higher outlier. Simply write is equal Q3, now simply add plus, bracket start, 1.5 times the interquartile range. Now close the bracket. So you can see it is actually a value that is beyond Q3 by an amount of 1.5 times that of interquartile range. Press enter, and there you can see this value is 30. And similarly for lower outlier, we can use the similar function, but this time we will have to subtract 1.5 times interquartile range from Q1. So I would write is equal Q1 minus bracket start 1.5 times interquartile range, bracket close, press enter, and you can see it's showing an error simply because the value of lower outlier falls into a negative value. Don't worry, I'm going to put some outlier, then it will show a value. So the value for the high outlier is 30. If I'm going to insert something like 40, you can see it is represented as a single dot, which means this data is an outlier. Click over here, and if I'm going to grab this particular point and bring 40 out of the data, you can see there is no outlier this time. And similarly, let me remove it from here. Let me insert something like minus 15. Since we have inserted a new value right over here, minus 15, the interquartile value would be changed now, and so is the case with Q1 and Q3. So the Q1 would be, let me come over here and include this data into it, press enter, this is the new value. And similarly for Q3, bring your cursor right over here and include this data into it, press enter. Now the interquartile range is 10, and let's calculate the lower outlier now, is equal Q1 minus bracket start 1.5 times interquartile range, bracket close, and you can see it shows the lower outlier is minus 9. Now click on the box plot. You can see this minus 15 is not included in our data, and let me extend it to include minus 15 into our data, and there you can see this single dot at minus 15 is our lower outlier. Let me press Ctrl Z to have a box plot without the outlier. So the data from the bottom whisker up to the start of the box plot is 25% of the total data. And similarly, from the start of the box plot up to this particular line, it is again the 25% of the data. And similarly, the 25% of the data lies between this line and the end of this box. And the last 25% of the data lies between the end of this box and this particular whisker. So right over here within the box, we have 50% of our data, and 50% of our data lies beyond and below the box. Now let me show you how we can actually plot two box plot. So over here you can see we have some physics and chemistry score data of some students, and let's have a comparison of these two. So simply select the data like this, go into insert tab and choose this box and whisker plot, and there you go. In the chart design, we can actually choose this particular, that is style 5, so that it could show the legend as physics and chemistry, and we can visually see the median, the minimum, the maximum score in our box plot. So that was it for today's tutorial. I hope you have found this tutorial useful. Please give this video a thumbs up, subscribe to my channel, and thanks for watching.